This video is brought to you by Sporlan, quality, integrity, and tradition. Well, we got a call on a walk-in cooler that's not working right. They're saying it's like 50 degrees in here. Let's get back up in here, see what we got going on. It's not iced up. There's a digital stat right here. It says 50 degrees. So yeah, looks like the coil's a little bit dirty, but we're gonna have to go up onto the roof because it looks like it's calling. Okay, so we come up onto the roof. We've got a couple different condensing units here. This is our unit in question. Well, that's not good. Condenser fan motors are running, but it's cold condenser. So what I mean by it has a cold condenser is when the compressor runs, right, it's moving heat, okay? The whole refrigeration cycle is moving heat from down in the evaporator up to the unit, and then you also have the heat of compression. So with the heat from the refrigerant that is absorbed down at the evaporator and the heat of compression that the compressor is creating, the condenser typically is a lot warmer than the ambient temperatures, okay? So when you walk up to this unit and you find that the condenser is cold but the fan motors are running, there's a major problem there. So that's the whole point that I'm trying to make here. So yeah, it's not good at all. We're gonna have to get this guy opened up, get all the panels taken off, see what we can find. All right, both condenser fan motors are running. The compressor is not. The compressor's warm, but it's not burning hot, but it's definitely warm. We're gonna start by checking voltage, and we're gonna get some probes on this guy to see if there's gas in the system. Definitely got a strong vibration. This equipment is really beat down. It's like our compressor contactors down here. So we'll get in on that real quick. All right, got the Fieldpiece SC480 right here. We're gonna check incoming voltage. Line 1 to 2, 209. 2 to 3, 209. 1 to 3, 206, okay? So we have three-phase power coming in. Let's check the load side of the contactor. 1 to 2, 63 volts, that's not good. 2 to 3, 109 volts, that's not good. And 1 to 3, 207 volts. So that's a problem. Let's look for a voltage drop across the contactor. Line 1 has 0. Line 2 has 120 volts measured across the contact. And now, so we've got a massive voltage drop. Honestly, I bet you it's going to be a bad contactor, but we're going to go ahead and power cycle the unit. Or not power cycle, but we'll shut it down. Okay, and then we're going to open up that contactor and have a look inside there and see what's going on in there. That's not allowing the voltage to pass through it. The fact that we have good incoming voltage is a good sign. That means that we have three-phase power coming into the unit, but it's just not exiting the contactor. More than likely it's going to be a failed contactor or pitted out contacts or something. All right, over here, this contactor, we pulled it open, and it's really pitted up in there, really bad. There you go. So we're sending, we went downstairs to go get a new contactor for this guy, and we'll hope that that's all that's wrong with it. We'll have to see. So we got the old contactor out. We're still currently wiring in the new one. What we found, obviously, look at the points. They're completely pitted out. Huge voltage drop across them. That's an issue, but all the little connectors were bad, several of them. So we're replacing a lot of the connectors because they were loose. And they just weren't making a good solid connection anymore. All right, we're getting big picture here, okay? We're taking the time, we're trying to figure out why the contactor failed and what potentially caused it, or other problems that can be part of this and or create other problems later. Loose connections at the contactor, that's some big picture stuff. You're solving some headaches later by looking at the big picture. So we're currently doing that. We've got the new contactor in, but we're having to fix the connectors, and then we're gonna hope that when we start it up, the compressor restarts. That's the hope. All right, if we did everything right, which we think we did, we double and triple checked it, everything's wired back in. It's a mess down there, but we should be good to go to turn it on. So 1, 2, 3, please don't blow up. Compressor's running, nothing blew up. So we're gonna let the system run for a while now. It's gonna be under a very, very heavy load. We're gonna go ahead and while we're letting it run, we're gonna probe up. We got a giant mess up here. We're gonna get some job link probes on this guy, and then we can analyze the system. But because we just turned it on, we're gonna let it run for a bit before we try to cycle it off again. We'll clean up wires and everything after we're done. All right, the system's been running for a few minutes. It's still 47 degrees in the box. I'm using the Field Piece Job Link app. Currently right now we have 19 degrees, evaporator superheat, 18 degrees, but it's still really high in temp, so the valve is flooding right now, it's opening. We need to give it some time to stabilize out. Now again, that is evaporator superheat, okay? So we're gonna let it run for a little bit, let it bring the box temp down, and then we'll test some more features, checking to make sure the defrost clock pumps it down and all that good stuff, but we're gonna let it run for a bit. So I came down here to check on the box. It's about 45 degrees. It's struggling to come down to temp, but I predict that the box has been down, meaning that that contactor's been bad for probably the whole day, I'd say, because they were closed on Thanksgiving. So today is Friday, November 26th, the day after Thanksgiving. So I predict this went down the night before Thanksgiving is what I'm thinking. All right, this equipment's doing everything it can. It's 43 degrees according to this in the box, and superheat is a little bit high, 17 degrees, 15 degrees, it's moving. That's not horrible for still being 45 degrees. It's still got to come down, so we just got to let it go. I'm going to seriously talk to the customer about replacing this equipment. This vibration is going to cause a leak eventually. This stuff is just beat down. These condenser fan motors, you guys can't see it, but they're vibrating really bad. But everything else is good. So yeah, I don't really have much more to say. Contactor's good. I guess the last thing we need to do is just test the defrost. So we're gonna click it into defrost and make sure that it pumps down. So you can see on the Job Link app, you can watch it as it's happening. So we should see that start dropping, and we wanna see it shut off because we messed with the wiring for everything. So we wanna make sure we didn't, you know, screw something up. So we wanna see the actual shutdown. So it's dropping. Let's give it a second. You can see like we lost connection with something for a minute, but the cool thing is it just retries and reconnects. So it's a cool thing about the Job Link app. Also, I probably didn't say this, but we are running a clear sight glass the entire time. So I don't see a problem with the charge. We're just waiting. So notice a second ago, it climbed up to like 210 PSI. I have a feeling that that receiver is slightly, like really close to the top, like it was struggling to pump down, because now it's kicking butt. It should be shutting off here any second. And if it's not, we may need to adjust that pressure control. Yeah. I'm gonna adjust the pressure control just a little bit because I don't really want to get below 10 PSI. These compressors don't like doing that. Also, you see how this fan motor's stopping before that fan motor? That could be an indication that the bearings are going bad. But okay, I'm gonna make a quick adjustment on the pressure control, and then other than that, this thing's doing everything it can. So we're gonna tell them to keep an eye on it, and I'm gonna strongly urge them to consider us replacing this equipment because it's just beat down.
Sometimes these calls can be difficult calls, sometimes they can be easy calls, but it's also very easy for an easy call to become a difficult call, right? So I just went around a whole confusing thing there. But always start with your basics, okay? You walk up and you check the symptoms. In this situation, I felt a cold condenser. I was like, something's not right. We started doing voltage checks. Obviously, we found a bad contactor, okay? Don't assume that it's just a contactor. Look further. Now, I evaluated the situation. I gave the customer a big picture diagnosis. I also repaired a couple things. The loose connectors, those are so important and easy to overlook. You think it's not that big of a deal, but those connections need to be tight. And if they're not, they're gonna lead to a high temperature situation, which is more than likely going to lead to an electrical failure of some sort, okay? Also, contactors have a shelf life, okay? What that number is, it just depends on the components and the things that they're made with, but realistically, contactors fail, okay? They have a life cycle and they do need to be replaced. So we need to keep on top of that kind of stuff. Now, this particular customer doesn't do routine preventative maintenance, so here's your sign kind of a situation, right? You know, they kind of get what they get, but doing routine preventative maintenances in the commercial side, I mean, even on the residential side, sales are easy if you just open your eyes and open your ears and just check what you're supposed to check. You know, sales don't have to be sleazy. You don't have to be selling death to grandmas or any of that stuff. You can simply just open your eyes and evaluate what's there and give them real, factual, honest information and let them make the decisions. Okay. In this situation, we replace the contactor. It's not that difficult. I looked at a lot of other issues and we gave them a big picture quote, and we'll see if they end up replacing all the equipment. They certainly would be smart if they did, but you know what? If they don't, it's okay, right? I really appreciate you guys making it to the end of the video. You're amazing. The support that you all have given me has been awesome. If you haven't already, please check out my website, hvacrvideos.com. We got merchandise available on there. There's a bunch of other ways to support the channel. There's information in the show notes. You can do it via Patreon, PayPal, YouTube channel memberships. One of the easiest way to support the channel, though, is simply just watch the videos from beginning to end without skipping through anything. That's the simplest way, okay? If you guys are purchasing any tools and you want to check out TrueTechTools.com, you may end up liking what they have. I love their selection and their pricing. I also have an offer code with them. I get a small commission when you use my offer code, and you get a discount, right? Big picture, one word, will give you an 8% discount. And then also, if you shoot me an email, I can generate an affiliate link. That affiliate link also helps me out a little bit too. Okay. I really, really appreciate you, and we will catch you on the next one. Okay.